Hello everybody and welcome to your first math lesson online in this time where coronavirus is forcing us to do it a bit different than usual. And let me take this here off. I think it's safe here. In this time where the coronavirus is forcing us to do it online and with OneNote and YouTube and so on. So you'll have to take theory from the script I gave you from these YouTube videos, and we'll meet together at the times that I told you where you can have a chat, a video conference, and also you have to do your homework regularly, because that's very important, right? Only with the homework you'll see if you really understood the theory. And to give you a motivation to do the homework, I had a great idea. If you do all the homework regularly and on time and thoroughly, you might get a prize that I'll give you. Something very precious at the moment is toilet paper. And to make it even more precious, I will sign it. So if you want to win this toilet paper, then do all your homework and do it on time. Then you might be the lucky winner of this toilet paper signed by me. So what I want to show you today is how to get the vertex of the parabola if we have it in the general form. Remember in the beginning, the first form I showed you was this one here, where it's easy to get the vertex, right? It's just u and v, but it's a bit more difficult to get the roots. And the other form was easy to get the roots. It's just x1 and x2, but it's more difficult to work the vertex. And what I showed you last lesson was a general form of the parabola. I showed you how to get from one to the other. So here I showed you how to get from the vertex form to the general form, and here from the roots form to the general form. And now I want to show you how to get the roots and the vertex if you have the general form. Well, to get the roots, it's quite easy. The roots is where the y-coordinate of the point is 0. So I just take the equation of the parabola and set this equal to 0. Now, you could use the midnight formula, or you could try to factorize. I think it's much faster if we just factorize it. We divide by -2. Then we have minus 2x minus 3 equals 0. X minus 3, x plus 1 equals 0. And these are the two roots of the parabola. To get the vertex, you have to use a technique that I showed you in the beginning of this chapter, if you remember, the completing the square. First, we need to get rid of this -2. To complete the square, you should have just x squared. So I'll factor out -2 here. And then I take this number which is in front of x, I divide it by 2, you get -1. Then you square it, you'll get 1. And I will add and subtract this number. So I have this here. Now I can use my normal formula backwards. This is x minus 1 squared, and this is -4. And don't forget to multiply everything with this -2. So this is the equation of the parabola. And from this we can get the vertex. So this is how to get the roots. Just set it equal to 0 and solve for it. And to get the vertex, you have to complete the square. Okay, let's do another example here. So this is the new parabola. Again, to find the roots, I set this equals 0. This time I'll use the midnight formula just as a repetition. So it's negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And so we have 12 plus or minus the square root of 144 minus 4 times 1.5 is 6. 6 times 25 is 150. Now what does it mean? If it's negative, I hope you remember this, then it means that we have no solution. And if there is no solution when I'm trying to get the roots, then it just means that there are no roots. How is this possible? I'll show you later. First, let's get the vertex here. I factor out 1.5. If I want to divide 12 by 1.5, 1.5 is 3 halves. So I divide 12 by 3 halves. I divide by 3, multiply with 2, we get 8. And 25 divided by 3 halves, it's 25 divided by 3 times 2, it's just 50/3. Then I take this number here and divide by 2, it's 4, then I square it, we get 16, and I add and subtract this 16 here. Now I use the binomial formula backwards, and here 16 is 48/3, so I have negative 48/3 plus 50/3, it's 2/3. And I multiply everything with 1.5, so I have 1.5 times x minus 4 squared, and 2/3 times 3 halves, it's just 1. So the vertex is at 4, 1. Okay, now to come back to the previous exercise where I tried to get the roots and I found no roots. This is a connection we have between geometry and algebra. If you remember from the first part of this chapter, the discriminant tells you if we have 2 solutions, 1 solution or no solution. If the discriminant is negative, it means it has no solution, and it just means that the parabola does not intersect the x-axis. If it does not intersect the x-axis, we have no common point, right? If it touches the x-axis, then we have just one point here where the parabola and the x-axis, or where the parabola has y equals 0. And this means we have just one solution. If the parabola intersects at 2 points, we have 2 roots. And this means that the parabola has 2 roots. That the discriminant is positive. Sorry, that's what I want to say. And so that's the connection we have from the previous part of this chapter with this, what we're doing right now. And here are some exercises where you can practice this. And this one you really should do by completing the square. That's important here, okay? Just to practice this a bit more, because in a minute you will see that you can do it much faster, but you really should practice this square. And now if you remember, some weeks ago I showed you that the sum of the solutions, do you remember, that was minus b over a? And if I want to get the coordinates of the vertex, the vertex is always in the middle of the 2 roots. So I take just the average of the 2 roots and I'll get the coordinate of the vertex. So that's what I'm doing here. I take the sum of the 2 roots, divide by 2, and I'll get this nice little formula here. The coordinate of the vertex is minus b over 2a. This will be very important in a few weeks when we have optimization problems. In the optimization problems, we try to get the maximum of of a function, or sometimes it's also the minimum. It's just the point where the parabola turns, and this is how we'll get the coordinate where the function has a maximum or a minimum. And I want to show you here, that is the same that we had here, right? Same function. Remember, we got 4, 1. And now I'll use this nice little formula here. It's minus b, so it's, let's write it down here. So it's minus negative 12, that's plus 12, divided by 2 times 1.5. Oops. 2.1.5 is 3, so we have 12 over 3, that's 4. Much faster than this, right? Isn't that useful? And for the y coordinate, I just plug this 4 into the function. So I have 1.5 times 4 squared minus 12 times 4 plus 25. This is 1.5 times 16, 24. This is 48 plus 25, so 24 plus 25 is 49, minus 41 is 1, so the vertex is at 4, 1. You get the same result as before, just much faster, and so you can practice also this formula using in this exercise here. And you really should also do with completing the square. You might think, why should I do this if we can get it much faster? But you should practice this completing the square. If you ask my 4th class students, they have seen that it's important when you want the center of a sphere and the radius and so on. So just to practice this, do the homework. If you have any questions, you'll meet me online. You can ask me whatever about this exercise and so on. So that's it for today. If you have any questions, you can ask me online or just drop me an email and do this homework here. And if you don't get motivation for the homework, don't forget the toilet paper. Okay. Bye.